Electricity is moving electrons. Electricity is moving electrons. Electricity is moving electrons. When they move from you to me.
Here you can see a simple circuit containing two resistors, where you can take measurements to determine the value of the resistance of each component, measured in ohms, where that resistance is a property of the particular component. In this video you're going to find out about a property of materials called resistivity, and you're going to find out how it relates to resistance of components.
You've talked about resistance of components measured in ohms, and the resistance is a property of a particular component. Okay, I want now to talk about resistivity, which is a property of the material that components are made out of. So let's think about some of the experiments that you've done and see if we can use them to work out what resistivity is and what affects it. So you did an experiment where you investigated how the length of a piece of nichrome wire affected its resistance. And you found that the greater the length, the greater the resistance, and you even found that it was a nice straight line graph, so we can say that the resistance R is directly proportional to the length of the wire L. Okay? Now I want you to think about two pieces of wire, two pieces of nichrome wire in parallel. So the same length, the same thickness, so they both have resistance R. Okay, and because they're in parallel, you get 1 over R total equals 1 over R plus 1 over R, which equals 2 over R. So R total is R over 2, a half of R. So by putting them in total, with having two of them, we've got half the resistance. Okay, and what I've done here is I've doubled the area. So by doubling the area through which the electrons can travel, we have halved the resistance. So from that, I can say that the resistance is proportional to 1 over the area. So the bigger the area gets, the smaller the resistance gets. So if I combine these two relationships now, I can say that R is proportional to the length divided by the area, and I can turn that relationship into an equation by adding a constant. So R equals a constant, Greek letter rho, times L over A. And this constant of proportionality rho is what we call the resistivity, and it's a property of the material. So for different materials of the same shape and size, with different resistivities, they will have different resistances.
Here we can see the formula relating resistance, length of the wire, the cross-sectional area of the wire, and the resistivity of the material, represented by the Greek letter rho. We can change the length, increase the length, and you can see the effect it has on the resistance, and that agrees with the investigation that you did. If we increase the cross-sectional area, we're providing more electrons travelling along the wire, so we're increasing the current, which means we're reducing the resistance. And if we change the material the wire is made out of, that will change the resistivity. So we have a low resistivity like copper, so we have a low resistance, or a high resistivity like nichrome and have a high resistivity. Here we've got an exam question that involves the resistivity of a material. So it says the wire in an electric heater has a resistance of 75 ohms. It's 9.5 meters long and has a cross-sectional area of 1.4 times 10 to the minus 7 meters squared. Calculate the resistivity of the material. So we need to start by writing down the formula. So we know R equals the resistivity rho times L over A. But it's the resistivity I need to calculate, not the resistance, so I need to rearrange this. So I need rho equals, well, it's going to be rho equals R. I need to multiply both sides by A, so A, and divide both sides by L. Okay, so I can now substitute in the values in the question. And there are the three values. So first I need R, so that's 75 ohms, multiplied by the cross-sectional area, which is this value here, which is 1.4 times 10 to the minus 7 meters squared, divided by the length, which is 9.5 meters. Just one little check, that's in meters squared and that's in meters, so that's okay. Okay, so I now need to use my calculator to work out the value, and 75 times 1.4 divided by 9.5 comes to 11.05, and that's multiplied by 10 to the minus 7. So, to give my answer now, I need to decide how many of these significant figures I need to use. So if I look here, I've got 1.4, that's two significant figures, 75 is two significant figures, 9.5 is two significant figures. So I'm going to give my answer to two significant figures, so that's going to be 11 multiplied by 10 to the minus 7. And then we need to look at the last part of the answer. Give an appropriate unit for your answer. So I'm going to work out some units here. So resistivity equals R, which is resistance, which has units ohms. So I'm going to put the ohms in. Times, well, I've got area, which is meters squared, divided by length, which is meters. So a meter squared divided by meters is just going to leave me with meters. So the units are ohm meters.
It's the power that lights the night. It's the power that runs machines.